As a bit of a technical subject, totally compared to the roof gardening, which was addressed by Madam Sridevi. Okay, I'm also impressed with your presentation, Madam. My roof is quite open. Maybe I will take up the roof garden with your help. Right? Thank you very much. Right. See, this is regarding type of construction and the construction related subject, totally technical. Well, sustainability, it means to support or to keep a process going, and a goal of sustainability is that life on the planet can be sustained for the foreseeable future. This is what we want. It should be sustainable. Life on the planet should be continuing. Three components of sustainability are environment, economy, and society. To meet its goal, sustainable development must provide that these three components remain healthy and balanced. Furthermore, it must do so simultaneously and throughout the entire planet, both now and in the future. Now, sustainable development is often defined as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Worldwide, people are currently using 20% more resources than that can be generated. Well, it can be grouped in three circles like this: environmental protection and enhancement, social progress, economic development. Altogether, it is a sustainable development. Sustainability, environment. At the moment, the environment is probably the most important component, and an engineer or architect uses sustainability to mean having no net negative impact on the environment. Thus, the term sustainable has come to be synonymous with environmentally sound or friendly and green. That's what we are nowadays talking, everything about green buildings concept. So climate changes are happening. The most troubling for the long-term health of the planet and for the goal of sustainability are the climate changes resulting from the thinning of the ozone layer and the progressive decline in biodiversity resulting from loss of habitat. We are seeing this much happening in New Zealand, where there is a hole has happened in the ozone layer and the people have the effect there. Economic sustainability and environmental sustainability are very closely linked in this. Yes, environmental degradation is also happening. It's because of the basic needs to meet this environmental degradation is automatically happening in this. Now, sustainability, where the construction materials required for the building we have been producing. In the manufacture and use of construction materials, the critical elements of environmental are utilization of resources, embodied energy, and generation of waste materials. These are the issues that engineers and architects must consider when planning and building a structure. Yes, we have been using the construction materials, right? How are you producing the material? Construction, its life cycle, and demolition. Construction, life cycle, and eventually its demolition. In all these processes, we have the energy factor which is coming up. Welcome, Achuri. So manufacture is an essential element in computing the environmental impact. Are the raw materials renewable? Are they scarce? Are they important to the global environment? How much energy is required in the manufacture? How much waste is produced during the manufacture? What impact do these wastes have on the environment? These questions are very important while we are using the materials for the construction purpose. The construction process also involves some expenditure of energy and produces some waste also. Can materials be used that have less environmental impact? How much of each manufactured material is, how much waste is produced? What is the impact of the waste on the environment? Some of these questions can only be answered for a specific structure. We have been watching while you are producing the clay bricks, is a wastage to an extent of 20 to 30%. While we are producing autoclaved aerated concrete blocks, AAC blocks, yes, there is a 40 to 50% wastage, but then this wastage is again used in the road fill material and all that, but it should be reusable. The lifetime repair and renovation, lifetime of the structure has a direct impact on sustainability. The most important point here is the lifetime is directly controlled by the durability of the construction material. Durability plays a major role. We look at this building, is it a durable building, right? The building is damaged. The plastering is peeled off. There are leakages, and then the water is penetrating through the plastering into the building, right? So some of these issues like we are not provided a cover and the concrete is peeling off and the building is not durable enough. Yeah, here also the sunshade is damaged because of concrete peeling off and moisture penetration into the building, right? So some of these buildings, as we can see, most of them are government buildings. They are getting damaged because of the faulty construction and faulty material usage. Nowadays we are getting the durable houses in the form of monolithic construction. It's called as Maivan construction by using the aluminum shuttering, pouring concrete into that, and there is no brickwork used at all. So they are more durable, more impermeable. Yeah, there is no water penetration into the building, no moisture penetration, right? So they are some of the beautiful buildings that are being built in Andhra Pradesh for PMAY. They are also built in Telangana also, right? Is all built with monolithic construction, Maivan construction, what they call. It's also called as a shear wall construction. Actually, there is no need of paint also when it is a concrete surface, but people have a passion towards paint. That's why the paint is applied. They're all called as a durable houses because there is no moisture penetration. This is what we convinced the government that let the buildings be maintenance free. By constructing these buildings, they are maintenance free. There are no cracks, no moisture penetration, totally concrete walls, very impermeable, moisture resistant and all these. Some of these buildings built at various locations across Andhra Pradesh, the various types of buildings which are built there. Now the building, after the purpose is served, it is no longer required. We are demolishing it, but while we are demolishing, how are we going to reuse this material? This is something to be thought about. How are we going to reuse? Where are we going to reuse? Is it going to the filling purposes at some locations? Okay, and then the energy. How much energy we need to construct the buildings? Even for the constructed buildings, what is the energy that is going to be used? Are the factors to be thought about? Demolition. Yeah, demolition nowadays is with the chemical process. We are just building the multi-story building at one stroke. In a few seconds, whole thing is coming. Or otherwise, the machines have come to demolish the building. Again, where should this material should go? Is the factors that should be considered in the demolition process. There is certain energy waste generation. Where should this waste to go? Is to be thought of. Can we recycle this? Is the things that we have to consider. Now we have predominantly two materials to be used for construction. One is concrete. Concrete is pretty strong in the construction. It is most impermeable, no leakages, okay, and pretty strong. It can be a 100-story building. Yeah, the tallest building what you have seen nowadays is in Dubai with 828 meters. It has got 160 stories concrete. The remaining 80 stories is built of steel with composite construction, with concrete floors, right? So it can be made both ways also. So concrete is pretty strong. Yeah, some of the buildings built by architect Jihad, right? So then comes the steel. Yeah, steel is also a very versatile material which can be used, but you have to take some precaution for the steel construction in terms of fire resistance to be provided by applying the suitable fire resistance paint, as well as you have to apply the corrosion resistance paint to see that it should not be corroded. But at the same time, steel can be encased in concrete also to ensure that it can be given the fire resistance as well as the corrosion resistance. Now comes the precast construction and its sustainable issues. We'll talk briefly about precast construction. PEB buildings, nowadays we are coming up with precast columns, precast beams. Only the roof is made up of purlins and a roofing system because that is less cheaper. And these columns and beams are made with concrete precast columns, and it is fire resistant, fireproof, wonderful. The precast is coming to the industrial structures also. Even for the water tanks, we are doing the precast into the water tanks also, right? But doing this precast this thing, and then the precast staging is all done. Very soon we'll be doing for the engine tank on the rooftop also. This way they are saving a time of about 4 to 6 months, even for the water tank, is something that we are doing in bonus for the Orissa government. Precast construction technology, wastage is less, and a key factor of building construction is the durability, because the concrete, most of the time, M40 concrete is what we adopt, because it is poured on the table, it has to be lifted out the next day. So the concrete poured is M40, very high strength concrete, thereby it is durable and impervious. It's only the joints between the walls will be providing the non-shrink grout, which is stronger than the M40, M60 strength is what we provide. And then buildings consume 60% of the electricity generated and 30% of the primary energy, such as natural gas, 25% of the national output of greenhouse gas emission, 10% of potable water, and employ 30% of raw materials. This is one information that we have. But then precast concrete contributes to sustainable practice with an integrated design approach, otherwise called as holistic whole building approach is what we adopt, thereby which is using materials efficiently, reducing construction waste, and site disturbance and noise is less. All IT companies for their expansion are using the precast construction, thereby there is no dust, no noise, only the elements will come, and then they partition that area, get connected without any dust and noise, which is a beauty of this construction into that. Sustainability, when you look at it, is a high performance building, cost effectiveness, it is secure. We have to look at the functional issues, aesthetics, productive, historic, and accessible. All these things comes under sustainability and high performance buildings. In precast construction, reduced material and energy is used, emission produced is less, building has an impact far beyond those of building themselves, such as less number of new quarries are needed, and by using fewer materials, less number of new power plants are needed to be constructed. By using less energy and less pollution is emitted into less emission to air means a reduction in respiratory conditions such as asthma. By using less water, a reduction in demands on the infrastructure. Singapore country has declared that their construction is totally precast, no more cast in situ because of the dust that it is generating, whereas in the precast there is no dust at all. No dust at all. Elements will be manufactured at the industry, they will come to the site and simply get connected. Thereby there is no dust at all. So eventually we'll move forward. When India also has to go towards that with more and more industries to come. So basically you have cost of green buildings by about 2% more, but then this 2% increase in construction cost will result in a saving of 10 times the initial investment, which is a greater fact. Buildings with good daylighting and indoor air quality are both common features of sustainable buildings that have increased labor productivity and worker retention and day's work. These benefits contribute directly to the company's profits, which is good enough into that. This integrated design, which we are talking about, it requires coordinating between architectural, structural, civil, electrical, mechanical designs. Design is completely frozen before an element is produced. All the electrical conduits will go into the walls, right? And the design is to be frozen. Even plumbing pipes will go into the walls. A well-insulated building with few windows that faces east and west will require less heating and air conditioning. So while planning a building, we ensure to see that lesser windows are provided on east and west. We can have more on the north, including providing the glazing, which is an advantage which architects will take care of predominantly. These are some of the integration strategy and sustainable attributes. Hollow core panels, we use them as ducts. Precast panel as interior surface. Thermal mass in combination with appropriate insulation levels in wall. Design wall panel to be dismantled for building function changes. Yes, it can be done. And durable materials. Some of the sustainable attributes are there, saves in the material and other things. Natural resources such as daylight, trees for shading and ventilation can be an integration strategy. Reduce and recycle construction waste. Okay, in precast production of the material itself, there will be very less wastage will be there. IGBC comes up predominantly saying 3 R's: reduce, reuse and recycle. These 3 R's are also well taken care in the precast construction also, as well as in the building industry at large. So precast and precast concrete can be designed to optimize or lessen the amount of concrete used. Suppose if you are looking at it, we are using load-bearing walls instead of a framed construction for the multi-story buildings, just like in the monolithic construction or in the precast walls, whereby the wall thickness is lesser, no more brick masonry or plastering, thereby a lot of economy into the construction, no plastering, no painting, which is a beautiful advantage. And in precast construction, we're also using the fly ash, slag cement and silica fume are being used in that, whereby the waste materials of slag and other things is a great benefit into that, thereby generates less amount of waste with low toxicity. And reuse products, repair what can be used, as precast components can be reused when building is expanded, quite possible to do so. Concrete pieces from demolished structure can be reused to protect the shoreline. Precast process is self-contained. Formwork and finishing materials are reused. Predominantly what happens, the difference between precast and conventional construction is that in precast construction, predominantly they use the steel plates, whereby you can use it number of times. In the cast intensive construction, it is predominantly woodwork, where it can be used only about 5 to 6 times. Thereby, the cost of construction becomes lesser in precast construction. Recycle as much as possible, which includes buying products with recycled content. And concrete in most urban areas is recycled as fill or road base. Wood and steel forms are recycled when they become worn or obsolete. Many cement plants burn waste derived fuels such as spent solvents and used oils in the manufacture of cement itself. Materials in concrete and its resistance, data gathered in life cycle impact are often grouped into 3 broad categories: materials, energy and emissions. So what are the raw materials? Approximately 0.73 kg of raw materials, excluding water, are required to make for 0.45 kg of cement, primarily due to the calcination of limestone. Solid waste from precast concrete plants is insignificant. Waste is about 2% of the mass of concrete. That shows that is used in production. 95% of this waste is further beneficially reused through crushing and recycling, resulting in about 3 kg per cubic meter, about 0.1% of actual waste. So it shows precast concrete has lesser waste is a great advantage. Fuel and energy in the precast construction also, by using these products, the precast construction we use very less energy in the production of the precast elements. Durability, more durable because it is precast concrete walls and modular elements are repeated in the production, and that gives a very good edge over the in-situ construction in the precast, more durable. Being produced in the factory, precise covers are maintained in the factory. Quality control is very precise, whereby your elements will have a very correct cover and it will have a very good corrosion resistance to the steel, right? Concrete is resistant to wind, cyclone, floods and fire because all these walls are earthquake resistant walls and they are more resistant to the weathering actions such as cyclone or wind force or earthquake force being concrete itself, precast concrete. Yes, fire resistance is very good for the concrete element compared to steel and other material. Concrete has natural 2 hour fire resistance. If you want to increase it to more than 2 hours, then IS code has given increased cover to be provided to the concrete element. Otherwise, you can also use some more paint elements to be provided, if not to the concrete other element, and improve the fire resistance. Precast concrete can be economically designed to resist tropical storms, cyclones and wind. Yeah, being concrete element is not subjected to, even if it is water enters, it will not bother much for the concrete, gives very good resistance to that. Very good resistance again at the cake, solid elements. If the total building is made of concrete walls, then the building hardly deflects due to the earthquake, hardly by about a 30-story building, hardly deflects by 30 to 40 mm, as what has been seen by us into the design of Zone 3 or even Zone 4 also, when the walls are built with concrete. So thereby that shows its strongness in the concrete. Yeah, weather resistance is also good because it is very impermeable. Water is impenetrable through the concrete. Ultraviolet resistance is too good with the concrete element. It gives very good resistance. Albedo is a solar reflectance. Solar reflectance is also very good for the concrete surface. It involves a bit of theory. I don't go much into that. But traditional Portland cement concrete generally has an albedo, a solar reflectance of approximately 0.4, and it has got, concrete has got a very good emittance also. It has got a thermal, solar reflectance is good, thermal emittance is good. Nowadays, we are proposing buildings without paint. One of such building is coming up at Bachpalli now, where the college we have proposed no paint to the building at all, both internally as well as externally. Thereby is a maintenance-free building. A good information about emittance. Again, emittance, some more information about measure of the solar radiation. Will not go much into this. Moisture resistance is good. Okay. Now what about thermal mass and nocturnal effects? Heat store and heat release in the night time. Heat is stored in the daytime. During the night time, heat is released. It's a very common phenomenon. And your thermal mass and nocturnal effect, some more information about it. Environmental protection is good. Yeah. One goal of sustainability is to reduce radiation and toxic material. Concrete gives very good protection against environment. Radiation toxicity is again good in the concrete element. Precast concrete is predominantly concrete. Is very good against radiation. Just keep this. And then radiation shielding concrete. Radiation shielding concrete is a composite based concrete that was developed in the last few years with heavy natural aggregate such as magnetite or barytes. This is some of the information. Yeah, the gamma rays, increased distance, use shielding, and the last slide shows where it is a concrete wall, you have a very good shielding, is what it means by the RSC, what I said. By using these materials, predominantly we use it for the nuclear energy plants. The concrete is produced with these aggregates, whereby it gives a very good protection against radiation and toxics. Yeah, evidence to noise also, and precast concrete production. Okay, there are some of the information about production. Reduced waste in terms of the precast, not much like the cast institute and other elements. Coming to the summary, sustainable practices contribute to saving materials, energy, and reducing the negative effects of pollutants. Use of precast contribute to these practices by incorporating integration design, using materials efficiently, reducing construction waste, site disturbance and noise. Concrete is durable, resistant to corrosion, impact and pests. Precast concrete structures are resistant to fires, wind, hurricanes. Light or natural colored concrete reduces heat island, thereby reducing outdoor temperature, saving energy, reducing smog. Recycled materials such as slag, fly ash, silica fume are all used in precast construction. Concrete structures in urban areas use recycled into fill and road-based material at the end of their useful life. They are generally made of abundant local materials. Thank you very much.